Alright then, welcome. Today, like I said, we are going to be discussing how to calculate the radius of the parallel of latitude. A very important topic, most especially for our students writing the JAMB, students writing the WAEC, and also students writing the NECO. Without taking much of your time, let us see what we can do with this. Now look at this. These are the kind of questions you are going to be finding here. You are likely going to see your exam. They might ask you to find the radius of the parallel of latitude of the following. They might give you just a single degree, the 69-degree north. They might give you a position, or they might just give you a location or a point. So now look at this now. Let's say you have the Earth. Let's say you have the Earth of this nature, and let's say this is North Pole and this is the South Pole. But what we're talking about is calculation of the radius of the parallel of latitude. When you say parallel, that means you have two latitude lines, horizontal lines that cannot meet each other. So let's say you have this, and of course, this is your Greenwich meridian. And of course, this is your equator, east, west. This is your equator. Now, I want you to understand that this is a latitude moving in what? In the horizontal movement of what? A great circle or a line that is moving from the east and sinking at west, which you call the equator. And let's say you have another latitude at this junction here. Now, in this nature, we have two parallel latitudes now. So what you have to do now is this. Let us say, for example, let us say this is a point. And let's say this point O. And this is another point, let's say point K. We have these 2 points now. And of course, this is meeting this angle here. This is called a radius of an angle. And let's say this radius, which is the radius of the parallel here, small r of latitude, and this is the radius of the Earth. Let us call this big R. Are we together? So I don't know if you can see what I'm doing. Okay, let me extend this a little bit so you see what I'm doing here. So as having something of this nature, at this point, this is big R, and of course this is small r. Small r. So this is what I'm trying to show you. And this is K and this is O. And let's say this is the point P. So having drawn this, I want to understand that this will lead us to something of this nature. This will lead us to something of this nature. Something of this nature. So now we're having something that looks like this. You're having this, where this is your R, and remember there's an angle here. This angle is alpha, this angle here too is alpha. Now, in this case, if this angle here is alpha, and this angle, this alternate angle is just going to be alpha too. So you can see the nature of this angle, is in alpha and alpha. So, and this angle here can be in degree. So definitely this is our position K, and this is O, and this is P. If you bring out this is a height. This is H, that's the distance from here to here. So in this case, if you bring out this, you have something like this, of this nature. Here, this is alpha, the angle, and this is H, the height. This is small r, and this is the radius of the Earth, and this is P, position P, and this is O. So I want you to understand that with this, if you recall your Socatua, your Socatua, SH Socatua, you can actually get this side using your Socatua. Remember that sine. Now what sine? Sine alpha is equal to opposite over hypotenuse. Where is the opposite? H. And where is the hypotenuse? R. So in this case, H is equal to R sine alpha. In that similar case, similarly, remember we're talking about radius of the parallel of latitude and not the radius of the Earth. Similarly, in this case, if you apply this, if you remember your cosine, your cos alpha will be equal to your adjacent over your hypotenuse. Where is adjacent? R. And where is the hypotenuse? Your hypotenuse is R. So in this case, your R, which is the radius of the parallel of latitude, is equal to R cos alpha. This alpha you see here is now the angle in degree, or should I say the point in degree, which is your latitude in degree. Your latitude in degree. So with this formula, you can solve any question on radius of the parallel of latitude. That means R is equal to R cos alpha. This alpha is your latitude in degree. This is the radius of the Earth, and this is your radius of the parallel of latitude. So using this, we are going to solve these problems now using this formula here. So now if you look at it, you apply this formula for number one. Let's say for number one, since your alpha line is 69 degrees, which is your latitude. Remember we said in the last class that latitude is that imaginary line that is running from the east to the south, east to the west direction, and it is projecting upward up to 90 degrees to the north, or downward up to 90 degrees to the south. So in this case, since this is degree in north, it means that this is a latitude. So if you apply this formula, it becomes your radius of the parallel latitude equal to r cos alpha. For number 1, r cos alpha. Remember, r is a constant, which is the radius of the earth, which is equal to 6,400 kilometers. So in that case, this will be equal to 6,400 cos the angle, in this case 69. So which is equal to 6,400 times cos 69. So when you point your calculator, you notice that cos 69 is equal to, you point your calculator, cos 69 is equal to 0.358. So let's say 0.358 so let's give it at 0.358. Let's give it at this. Let's give it like this. Don't approximate. Just keep it like this. If you don't want to interfere with your calculation, you can just go straight and say 6,400 multiplied by cos 69. It will be equal to 2.293. Approximately that's 2.29. Approximately 2.3. 2.3. That is the radius. So in this case, you've gotten the radius of the parabologram. Same way, if you apply this, if you look at your number 2, which is this is the latitude, and if you look at number 3, this is the latitude. Look at number 4, this is latitude. You just have to be applying this formula here. You still get this answer for number 2. For number 2, if you apply the same formula, it will become r is equal to, like here, r cos alpha, that means r is equal to 6,400 cos 54 degrees. So if you do that, you get your answer. As you can see how easy it is. So I want you to use this to solve, go to your past question. You will see a lot of problems on this, and definitely if you apply this formula, you are going to get your answer correctly. So our next class, we shall be talking about the how to calculate for the distance along the parallel of latitude, and of course the formula for that is theta over 360 multiplied by this, which is r cos alpha. So when you apply that, you get your answer correctly. So in our next class, we're going to treat on that. Thank you.